This is a very interesting question. It states that block C, as shown in the figure, starts from rest and moves in downward direction with a constant acceleration. Okay, so it moves in downward direction, and let us suppose it is displaced by x. Knowing that after 12 seconds the velocity of blocks is 7.2 meter per second, determine the acceleration of A, B and C along with the velocity and the displacement of block B after 8 seconds. Okay, and we assume that block B is moving upward by Z and block A is moving downward by Y. And in this case we are going to use the work energy principle. Okay, so first of all let's define the various values of the tension. So this is tension T2 and this is also T2, and accordingly the tension at this point will be twice of T2, and this is the same string, so we are going to get T2 here as well as T2 here, and this will be coming as twice of T2. So this is same string, so this will be T2. Now this is second string, so let us call this as T1, and then this will be also T1 and this will be also T1. So ultimately this here we are going to get twice of T1. So it means by work energy principle we can say that work done by tension in an ideal thread is always 0. So mathematically that can be written as work done for tension T2 or net work done for tension T2 will be equal to 0. Now the displacement Y is in downward direction, where tension T twice T2 is upward direction. Okay, we can say that, let us draw it here, for mass A, or rather block A, so this is A block, tension twice T2 is upward direction and movement Y is in downward direction. So its work done, let us call that is WA for T2 is equal to minus twice T2 Y, and for block B we have block B is having a tension of twice T2 in upward direction and the movement is also in upward direction. So work done of B T2 will be equal to positive twice T2 into Z. Okay, let us call this as Z this way. So it means summation of this implies that work done of A with T2 plus work done of B with T2 will equal to 0. We substitute the values, we get minus T2 Y plus twice T2 Z is equal to 0. Sorry, it will be thrice, my mistake. Okay, because it is, this mass is having two tensions T2, so this will be thrice. So from here we can write the relationship as 2y is equal to 3z. So differentiating the equation, differentiating twice at equation 1, we get 2y is acceleration of A is equal to 3 is acceleration of B. So from here we can write the formula for AB. Acceleration of B is equal to 2 by 3 acceleration of A. Now similarly, we are going to use work done in tension 1 net equal to 0. So we have here 2 blocks. For block C, we have twice T1 and it is moving in downward direction by X. So work done C for T1 will be equal to minus 2 T1x, and for block B we have T1 tension and it is moving upward with the Z, so we can write WB or T1 is equal to T1Z. So we can say that this equal to WC T1 plus WB T1 is equal to 0. Substituting the values, twice T1x plus T1z is equal to 0. From here we can write that twice x is equal to z. That is equation number 2. Double differentiating twice, equation 2, we get this as 2x is for C, acceleration of C is equal to acceleration of B. Okay, from here we can write acceleration of C is equal to acceleration of B divided by 2. It is also given that both of them are block C start from rest and move downward. Okay, so since block A starts from rest, so B and C also starts from rest. So we are going to use the equation of kinematics. So we can write this as for block A, VA is equal to UA plus AA into T, and UA is given at 7.2. Okay, we can write VA is given as 7.2 and starts from rest, so UA is equal to 0 and time is given as 1.2. Yeah, time is given as 1.2 seconds. Okay, so it should be 1.2, not 12 seconds. So substituting the values, VA was 7.2, so 7.2 is equal to U is 0, and we find out acceleration of A into 1.2. So acceleration of A is equal to 6 meter per second square. We already know relationship between AB and A. We can write it, but acceleration of B is equal to 2 by 3 acceleration of A. So we put the values, 2 by 3, acceleration of A is 6. So this comes as acceleration of B is equal to 4 meter per second square. And similarly, we also know that acceleration of C is equal to acceleration of B divided by 2. So acceleration of B is 4. So AC will be equal to 4 divided by 2, that is equal to 2. So we can say that acceleration of C is equal to 2 meter per second square. And we are also going to find out displacement of block B after 8 seconds. Okay, so you can say that displacement of we are going to find out displacement of block B. Yeah, so displacement of block B after 8 seconds. We use the formula SP is equal to UB into T plus half AB T square. So UB is 0, so we get half. Acceleration of AB is 4, and time is after 8, so this will be 64. This goes by twice. So displacement of SP or S block will be equal to 128 meters. Okay, so this is the displacement of block B. So this completes the all the requirements. Question asked for acceleration of A, B, C as well as displacement of B after 8 seconds. Thank you.